Unit 8, Lesson 2, this is problem number 5. And so first I'm going to write this in condensed form. I have log base 2 of the quantity x plus 11 raised to the 1/2 minus log base 2 of the quantity x minus 3 equals 1. When I condense this, subtraction turns into division. Log base 2. On top, I have the square root of x plus 11, or I could have wrote it still in a rational exponent form like you see here, divided by x minus 3 equals 1. Now I'm going to go ahead and write this in exponential form. 2, the base, raised to the number on the opposite side, equals the square root of x plus 11 over x minus 3. So I have 2 equals this quantity. And then remember, I'm going to choose to do cross multiply. I can always put a 1 on the bottom of that 2. When I cross multiply, I have 2 times the quantity x minus 3 equals 1 times the quantity of the square root of x plus 11. 2x minus 6, well, 1 times that quantity is simply this. And you're thinking to yourself, like, how do I get rid of the square root? Opposite the square root is squaring, so I'm going to square both sides. On the right-hand side, I'm left with x plus 11. But now on the left-hand side, be aware that we're going to write this out, and we are going to go ahead and FOIL this. So I'm going to FOIL this. Front, outside, inside, and last. I'm going to move everything over to the left-hand side. Minus x, minus 11. I now have nothing remaining on the right-hand side. On the left-hand side, as I combine like terms, I have 4x squared. Okay, here's negative 24, negative 25x, and then 36 minus 11 would be a positive 25. If you see me make a mistake, please let me know. All right, what do I do next? Okay, so my next goal is it possible to factor this? If not, we can always use the quadratic formula. So, is it possible to factor? What multiplies to equal positive 100 and combines to give us negative 25? Let's see here. So 1 and 100, no. 2 and 50, that's not working. 4 and 25, that's not working. Anybody else thinking any combinations? 5 and what? 5 and 20. Oh, thank you. That should have seemed like an obvious one. 5 and 20. So here's where I think a lot of students in the rush of this may make a mistake. They may forget that because the leading coefficient is anything other than a positive 1, I need to drop it down underneath. Now in this form, we can easily solve. Opposite of negative 5/2, I'm going to check one answer of being a positive 5/2. 20 divided by 4 is 5. Opposite of negative 5 is a positive 5. These are the two solutions I'm going to check. So I'm going to come back up here to this original equation, and I'm going to check 5/2, and I'm going to check positive 5. Those are the two that I'm going to check. What do I mean by check? So if I have a positive and I add 11, it's still positive. If I have positive 5/4, which I know is just a little bit more than 1, by the way, and I subtract 3, it's going to be negative. But I can demonstrate that on a calculator for you. And we see we get a negative value in this region when I substitute in 5/2. This is an extraneous solution. Now, 5 plus 11, it's a positive number. 5 minus 3, it's positive. I only have one solution of 5.